Good morning, geometry. On Friday, I believe I told you guys that we would be working on the last two problems in the week 3 notes, which is true. And so that's all we're doing today. And then there will be a assignment left after this. That'll just be the same thing. But the reason we left these two is because they're trickier. So you can see with this one, this problem 4 here, it goes from this blue triangle, ABC, to this red triangle that's really stretched out, A prime, B prime, C prime. And then from there, it goes to this green triangle up here, A double prime, B double prime, C double prime. So it goes from this one to this one to this one. And from the blue one to the red one, we can tell that it kind of just stretches out. However, from the red one to the green one, it looks like it's reflecting as well as a different transformation at the same time, which is what makes these two problems a little bit trickier. So what we're going to do is just figure out these points. So first, let's see. I have A, which is 0, -2, and that is being mapped onto A prime, which is still 0, -2. So that one didn't change at all. Then I got B, which is -2, -4. And that's being mapped onto B prime, which is -6, -4. And then I have C, which is at -4, -4. And C prime is at -12, -4. Okay, so the A to A prime did not change, but B to B prime, the Y value stayed the same, and the X value went from -2 to -6. So it looks like either that added -4, or I guess it subtracted 4, or it was multiplied by a factor of 3. So when we look at C, we want to determine which one is it. Did it subtract 4, or was it multiplied by 3? So from -4 to -12, did that subtract 4, or was it multiplied by 3? It was multiplied by 3. So that means our X values here are being multiplied by 3, and that still holds with this A because 0 times 3 is still 0. So our X values are being multiplied by 3. And if I go all the way back up to the first page of the notes, this is one of these other non-rigid transformations. And when we have the X value changing, so it was 3 times X, this would be a non-rigid transformation with a horizontal stretch factor of, and this time it would be 3. So we can see how that worked out, because from this blue triangle to this red triangle, it kind of looks like it got stretched horizontally. It didn't get stretched vertically at all, didn't change its height, but it changed its width. So the first rule that we'll write is non-rigid transformation with horizontal stretch factor of 3. Why did I write an F? Okay. Awesome. And then there's another one because it goes from the green or from the red triangle to the green triangle. So we need to identify what this is now. So I'm going to do the same thing I just did, where I went from A to A prime. Well, now I'm going to go to A double prime. So from A prime, it goes to A double prime, which is, let's see, looking at my coordinate plane here, A double prime is 0, 2. All right, B prime to B double prime. So it goes from -6, -4 to -3, 4. -3, 4. And then from C prime to C double prime, let's see, C prime is at -12, -4, and C double prime is at -6, 4. Okay, so now let's look at our patterns that we have here. So from A prime to A double prime, the X value didn't change, but the Y value went from negative to positive. And it looks like the Y value did the same thing with the B and the C. It went from negative to positive. And the X value with the B and the C looks like it went from, well, -6 to -3, and then -12 to -6. So it looks like both of those were halved. So -6, half of that is -3. -12, half of that is -6. So that's what happened with the X values. And half of 0 with the A is still 0. So the X values were halved where the Y values were changed to positive. So let's look at our cheat sheet to see what this applies to, what happened here. All right, so I do see with my Y values switching sign, that looks like a reflection over the X axis, but the X value changed as well. So instead of going from XY to X negative Y, it looks like it went from XY to 1/2 X negative Y because the X was multiplied by 1/2. So, that was down here, yeah. Then we will say another non-rigid. With, so that was the X value was being multiplied by 1/2. So that was another horizontal stretch factor with horizontal stretch factor of 1/2 and reflection over x-axis. So there was a non-rigid transformation with horizontal stretch factor of 3, and then a non-rigid transformation with a horizontal stretch factor of 1/2, and a reflection over the x-axis. Or, if we wanted to write this out, so we started with our first triangle, which its points were all x, y. And then our second triangle, I think we said we multiplied the x values by 3. So it went to 3x, y. The y value stayed the same. And then our third triangle took half of whatever came in the first place. So in the first place, it's this, instead of x, it's 3x. So half of 3x is going to be 3 halves x. and then it flipped over the x-axis, which means the y values became negative. So it went from xy to 3xy to 3 halves x negative y. And that's all we got to have. But I mean, it's good to write this out too, just so we can describe it in words. Okay. And then continuing on. Identify the composition mapping rule, so it's the same thing. And we can do that. And we have another triangle named ABC. So I'm just going to do the exact same thing. So let's see. A is at 1, 3. And is being mapped onto A prime, which is at 1, 1. B is at 0, 3, no. B is at 0, 9. And is being mapped onto B prime, which is at 0, 3. And then C is at 3, 6. And it is being mapped onto C prime, which is at 3, 2. All right, hopefully we see the pattern that occurred here. The x values all stay the same. However, the y values are divided by 3. So the A value went from 3 to 1, B went from 9 to 3, and C went from 6 to 2. So it just divided them all by 3. So the first transformation that occurred was a non-rigid transformation with, and this time it was the y values that were being multiplied by 1/3. So with a vertical stretch factor of 1/3. Non-rigid transformation with a vertical stretch factor of 1/3. Okay. And then it looks like going from A prime, B prime, C prime to A double prime, B double prime, C double prime. It looks like that is either a rotation or a reflection, as well as a dilation. So let's see, let's figure it out. So A prime is mapped onto A double prime, which is at -2, -2. B prime is mapped onto B double prime, which is at 0, -6. And C prime is mapped onto C double prime, which is at -6, -4. Okay, so here we can see that our values, well, like with this A, it's going from 1, 1 to -2, -2. B is going from 0, 3 to 0, -6. And C is going from 3, 2 to -6, -4. So what's happening with every single value here is being multiplied by 2. Well, not just 2, negative 2. Because 1 times negative 2 is negative 2, 0 times negative 2 is 0, 3 times negative 2 is negative 6, and 2 times negative 2 is negative 4. So that accounts for all the coordinates here, and everything has been multiplied by negative 2. So if everything is being multiplied by the same number, both the x values and the y values are being multiplied by the same number, that is not just a non-rigid transformation, it's a dilation. So let's go back up and look at dilations. So a dilation, when the pre-image and image are the same shape but different sizes, both the x-coordinate and y-coordinate will be multiplied by the same value. So we can see here, this would be a dilation with a scale factor of 1/2. So since everything was multiplied by negative 2, this would be, well, what we just saw would be a dilation with a scale factor of negative 2. So that's what we'll say. So that was bad. Dilation with a scale factor of negative 2. So we had a non-rigid transformation with a vertical stretch factor of 1/3, and then a dilation with the scale factor of negative 2. So what happens with these dilations is that when you shrink it, when you multiply it by like 1/2, it's not just getting smaller on itself. So if I were to have this same triangle and have a dilation with a scale factor of 1/2, it wouldn't get smaller within itself. It would get smaller towards the x-axis, or not towards the x-axis, towards the origin. So it looks something like that. It would be shrinking, shrinking, shrinking towards the origin. And what happened here is when we multiply by negative 2, well, the closer to 0 you get, the closer to the origin it gets. But then once you get into the negatives, it pops through the origin. So what happened was it went right through the origin. Yeah, and then B went through the origin as well, and C went through the origin as well. So it shrunk real close to the origin, and then it popped through the origin onto the other side, and now it's in the negatives, and it's getting bigger because it's negative 2. So that's what happens when you multiply, or when you have a dilation with a negative scale factor. And I just wanted to show you guys that. So that's what happened there. And you guys, I believe that's all for today. Oh, actually, I should probably write it out like I did with, like here. So I will do that. Okay, so first thing that happened, we had a non-rigid transformation with a vertical stretch factor of 1/3. So that means it started x, y, and the y values were multiplied by 1/3. The x values were left alone. So it went to x, 1/3 y. And then it had a dilation with a scale factor of negative 2, which means this x and this 1/3 y are both getting multiplied by negative 2. So that is going to negative 2x, and negative 2 times 1/3 is just going to be negative 2/3 y. So it went from xy to negative 2x, negative 2/3 y. And that is the composition mapping that we can see here. I know some people were confused about like composition mappings. Composition just means more than one transformation occurring at the same time. So you have one transformation occur, and then you have another transformation occur. And there will be an assignment in Schoology that has to do with this, but other than that, we are done the week 3 notes. Thanks for listening.